Okay, with today's video, we start on page 3 of our Chapter 9 notes packet. Section 9.2, angles as rotations. Now, unlike the other day in class and the other night's video, we were looking at angles as interior angles of a right triangle. Well, now we're going to look at angles as rotations on the coordinate plane, meaning using the positive portion of our x-axis as the initial side of our angle. So before we begin, first, if an angle measure is positive, the rotation direction is counterclockwise. The direction of the rotation is counterclockwise if an angle measure is positive. If an angle measure is negative, the rotation is clockwise. So the standard position of an angle theta is in standard position when its vertex is at the origin and its initial side lies along the positive portion of the x-axis. So in other words, what I have here is just a piece of a pipe cleaner, all right? And if I treat the origin as the vertex, all right, this is the initial side. It's laying on the positive portion of the x-axis. And I'm just going to rotate this. If I rotate it 90 degrees, we see that this would be called the terminal side. That would be the positive portion of my y-axis. So here I have just a representation of a 90-degree angle. Right? So I keep this initial side here and then try to continue to rotate more. Okay. That's about another 45 degrees, so 90 plus 45. This would be about representation of a 135-degree angle. Rotate now, and my angle measure is, that would be a straight angle, 180 degrees. Again, keeping this as my initial, continuing to rotate. 90, 90, and 90 would be 270. And all the way back around would be 360. So we're looking at angles measures as rotations. I'll do that once more with just the one pipe cleaner. This is the initial side. That's where we begin. Quarter turn, 90 degrees. Another quarter totals 180. Another quarter, 270. And back around 360. Now I could continue, all right? I went once around 360 plus another 90 would put us at 450, and then another 90, 540, another 90, 630, and then finally twice all the way around 720. All right, so what we want to do is simply draw some angles. All right. So let's draw an angle of 30 degrees. So we start with the initial side here on the positive portion of the x-axis and 30 degrees. We know halfway between the positive x and positive y would be 45, so we're a little less than that. All right, so now take your pen or pencil and draw the terminal side, the ending side. This is our initial side. The positive portion of the x-axis is our initial side. And then where we end, this is our terminal side. And we'll just indicate our direction with this arrow. So this represents a 30-degree angle. How about a 170-degree angle? Starting here, always with the positive portion of the x-axis, that's our initial. 170 degrees, not quite 180. So 10 degrees shy of 180. And again, these are estimates here. So this would be my terminal side. my initial side, and we indicate the direction, 170 degrees. Again, positive degree measure, your rotation is counterclockwise. Next, 190 degrees. Always starting with the positive portion of the x-axis as your initial side, rotating 180, and then a little more, 190. So this would be the representation of that angle. Draw the terminal side, and then indicate your direction. 380 degrees. So I'm going 360 plus how much more? 360 plus 20 more. Now, how do we indicate that? Well, let's first draw the terminal side, the ending side. This was the initial, right? And to indicate that we went once around fully, starting at the origin, here I am, drawing our direction, meets up with 360 and goes just beyond it. And this is a 380 degree angle indicated here. Next, negative 100 degrees, all right? Negative 100, that means we would go 100 degrees in a clockwise direction. So starting with our initial side, always the positive portion of the x-axis, and now clockwise 100 degrees, there we are. Initial side, terminal side, and our direction. Next, any angle in standard position whose terminal side lies with, any angle in standard position whose terminal side coincides with the terminal side of theta is a coterminal angle. In the following diagram, the angles of 140 degrees and 500 degrees are coterminal angles because they share the same terminal side. All right, let's look at this. We have this 140 degree angle. All right, I'll try to leave that there in blue. And then we have a 500 degree angle. All right. So here's my 500 degree angle, showing the rotation in red. There's 360 plus I don't know, this guy doesn't want to stay in my fingers. Plus 90 plus 40 plus 130 more. Or 140 more. Okay. Let's see if I can do this with the blue pen. All right, so this is the 140. This is the terminal side, the ending side. Yeah, I think it's better with the pen. And now we have our other angle of 500, which was the 360 plus the 140 more. They share the same terminal side. So they're coterminal angles. To find the measure of a coterminal angle, you add or subtract 360 from the original angle. So we're just going to say plus or minus 360 degrees from the original angle. Right? If I took the 140 and I add 360, I get 500, which is a coterminal angle. I could also take the 140 and subtract 360, which is negative 220. That also would be coterminal. All right, negative 220. Let's see if I can get another color here. $180 and then 40 more and a clockwise direction would be negative 220. So all three of these angles would be coterminal. They share the same terminal side. Next, an angle in standard position whose terminal side lies on either the x-axis or the y-axis is called a quadrantal angle. So when you hear the term quadrantal angle, that's an angle of a multiple of 90 degrees. Let's just add the arrows here. We have our quadrantal angle of 90 degrees. Next, 180, 270, and negative 90 is also a quadrantal angle. I could keep going. If I take the 270, go 90 more, 360, another 90, 450. These would all, any multiple of 90 would be a quadrantal angle. Next page. We want to draw an angle with the given measure in standard position, tell which quadrant the terminal side lies, and draw and state the degree measure of a coterminal angle. All right, so remember our quadrants. Let's do that first. Our x and y axes are perpendicular to each other, and they divide the coordinate plane into 4 quadrants. Starting in the upper right, this is quadrant 1, and then going counterclockwise, quadrant 2, 3, and 4. So we first want to draw an angle measure of 60 degrees. So we're starting our initial side here is the positive portion of the x-axis, and our terminal side, 60 degrees, would be approximately about here. All right, and let's indicate our direction. So this is a 60-degree angle. Tell what quadrant the terminal side lies. This is the terminal side. It lies in quadrant 1. And then we want to draw and state the degree measure of a coterminal angle. Well, to get a coterminal angle, we can either add or subtract 360. Right? So we take our 60 and we add or subtract. We can do plus or minus 360. Right? If I do minus 360, would be negative 300. I want to draw that. We want to draw and state the degree measure. So negative 300, that would be a clockwise rotation of 300 degrees. That's the 270 plus the 30 more would put us right there, coinciding with our original angle, terminal side of 60 degrees, negative 300. If I added 360 to 60, that would bring us up to 420. So if it was added, it would be up to 420. And I would show that by starting at the origin, going once around, and then 60 more. And if I wanted another one, I can certainly add another 360 to 420. So in order to find a coterminal angle measure, you just add or subtract 360 from your original angle theta. Next, 120-degree angle. Starting here, positive portion of the x-axis, 120 is going to be 90 plus about, 30 more. I'll say approximately here. Let's draw the direction. That's a 120-degree angle. And its terminal side, its ending side is in quadrant 2. A coterminal angle, I'll take the 120 and I'll subtract 360. Negative 240. So the degree measure is negative 240 degrees, and let's draw that. 180 plus the 60 more. Okay, you can pause the video and try the next ones on your own if you like. 315 degree angle. 315. It's a little shy of 360. Starting here, going 270. It actually should be 45 degrees shy of 360, so it should actually bisect quadrant 4. The terminal side of this angle in quadrant 4, the coterminal angle, I'll take the 315 and subtract 360, get negative 45. So I'll coterminal angle negative 45 degrees, and we'll indicate that right here. Let me go back and label my 315 degree angle. Number 4, negative 225. Negative. Initial side, positive portion of the x-axis. Negative 225. That's going to be clockwise 180 and then 45 more. So it should bisect our second quadrant. Negative 225 degree angle. Coterminal with that, oh, let me write the quadrant down. That's quadrant 2. Terminal side lies in quadrant 2. Coterminal with that, if I add 360 to get the coterminal angle, yes, 135. And indicating that in red. Yeah, if you have the same, if you have two different colored pencils, that'd be good to do the same as far as drawing the original angle in one color and the coterminal angle in a second color. Next, negative 400 degrees. All right, let's just quickly draw an x and y axis. It doesn't need to be provided for you. Make sure we label them. Negative 400. That's going to be negative 360 and then negative 40 more. Negative 360 and then 40 more. There we go. Coterminal to that, I'm going to add 360. That'd be negative 40. What quadrant does our terminal side lie in? It lies in quadrant 4. Our coterminal angle measure, negative 40. If I added another 360, that would bring us to a positive 320, and I could show the positive 320. I'll do that in green. It'll be this way. It'll be positive 320. And number 6, 700 degree angle. And sketch an x and y axis here. 720. That's going to be 360 plus how much more? Plus 340 more. All right. So here I go. 360 and then 340 more. There's our 700-degree angle. What quadrant is the terminal side? Quadrant 4. And a coterminal angle, I'll take the 700, I subtract 360, and that's 340. So that would just be indicated by going once. If I subtract another 360, you get -20, and that would be indicated.
All cleaners will be going out to shovel right after lunch.
Okay.
Probably 12:30.
All right, just ignore the interruption there. All right, lastly, find 3 angles coterminal with the following angles. All right, 470. So we want 3 angles coterminal with the following. So to get a coterminal angle, again, you just plus or minus 360 from the original, or multiples of 360 also. All right, so 470, if I subtract 360, I know this video is kind of getting long, so I'm trying to move along. 470 subtract 360 is 110, and then subtract another 360 from 110 is -250. If I go once more, subtract 360, -610. So there's 3 coterminal angles. Next, for 755, if I subtract 360, you get -325. Subtract another 360, I'm at positive, I'm sorry, that's positive 325. Subtract another 360, I'm at negative. All right, backtrack. 755, subtract 360. 395. Subtract another 360, 35. And then subtract 360, -325. And our last one, -50. I'm going to add 360 to get 310. Add another 360, 670. And let's say I go back to -50 and subtract 360 to get -410. All right, thank you for your patience there. And this concludes our video.